And we can start. So my name is Arturs Lontons. I'm a technical marketing engineer at Zabbix, and I will be talking about a deep dive into TimescaleDB specifically, TimescaleDB partitioning, compression, and the mysterious chunks that we from time to time hear about, what those are and how they behave and what you should do with them or maybe shouldn't do with them. So first off, let's start simple. So why Postgres and why Timescale? So first off, if you're a Postgres admin, I think that's then the logical choice to go with, right? You'll feel right at home. You'll be able to do your own troubleshooting, your own tuning, and so on. There are tons of configuration options. It is a bit more complex than MySQL in my experience, but that gives us the necessary flexibility to fine tune it. It's open source, which is great. Zabbix is open source. Postgres is open source. That's amazing. TimescaleDB is the only database backend with Postgres, of course, that supports native history and trend partitioning. So if we use Postgres without Timescale, or if we use MySQL, then we'll have to write our own scripts. With Timescale, partitioning is native and also compression is native. And we can enable or disable compression, for example, and that's really great and really flexible. Next up, let's just briefly go through the deployment process, since I still think that many users are a bit afraid of Timescale and maybe how to deploy it. So first off, generally speaking, depending on the OS version that you use, but I think that's a rule of thumb, check the OS version, the Postgres version and Timescale version that comes packaged with your OS. Make sure that they are not outdated. Check our requirements page and download the latest supported version. Then install Postgres, create a Zabbix database and a Zabbix user on it, import the Zabbix database schema and the initial data into the newly created database with the newly created user rights. Then install Timescale. Real simple. You can just Google around for the instructions. It's really, really simple. And once installed, we can run the TimescaleDB tune utility to do some kind of basic general tuning. But if you're an admin or if you just wish to Google around, of course, there are maybe some individual tweaks and tuning that you may want to do. Then we have to enable the TimescaleDB extension. And here is the query for it. This is straight from our documentation. This isn't some unknown secret. This is, if you Google how to install Timescale on Zabbix, you'll find this here command. And then we need to migrate history and trends tables to support TimescaleDB. This, in recent versions in 5.4, comes in Zabbix SQL scripts package, so don't forget to install it. That's a new package for the most recent Zabbix version. It will stay there with 6.0 in the future. And then we need to zcat, we need to unarchive this here JZ archive. And this contains some migration scripts that will migrate our history and trend tables to Timescale. And these can take a lot of time. When I was preparing for this presentation, of course, I didn't have a really large database on hand on my literal laptop, so it was quick. But I do know that on larger instances, especially if the performance isn't up to par, it will cause downtime. This depends on the IOPS capabilities of your Postgres database. If it's on a remote machine, then maybe networking, and if there's maybe clustering in place, the networking can also affect that. So many sort of aspects to it. Ideally, what I would do, I would maybe run it on copy the database to a test environment, at least partially copy it and do a test, right? And just let it run overnight maybe and check if it's done. I think that's the best way, just to kind of measure how long it's going to take. It's always best to just do a copy if it's possible and then test it that way. So, but there are a couple of notes that you can actually miss out on. So check the requirements page and use only supported Postgres and TimescaleDB versions. For example, Postgres 12 with TimescaleDB 1.7, 2.0, or Postgres 13.2 or newer with TimescaleDB 2.1. Question is, so TimescaleDB 2.1, right? Can I use TimescaleDB newer than 2.1? So currently our requirements page still hasn't been updated. We still haven't thoroughly tested newer versions, but if you look at Zabbix bug reports or the GitHub issue over here that I mentioned, There have been known issues with newer versions of timescale. Compression policy keeps failing if the table uses integer and not big integer. Supposedly it's fixed by now. So if you have a home environment, a home lab, or a test environment, feel free to play around with these. Also probed our support a bit. They said that it looks to be fixed, but like I said, we haven't tested it officially. So be careful. I'd stick with 2.1 for now, maybe until Zabbix 6.0 comes out early next year, January next year. And then we can sort of see it'll probably be tested on 6.0, and then we can kind of give an official answer. Okay, what about 6.0 LTS? So currently, still Postgres 13 point something from what I saw, or probably newer. It already, I think, got updated. And TimescaleDB 2.01 to 2.3. And this is still in development until it comes out. These are just temporary placeholder notes, subject to change as we test newer things around. Just requires extensive testing. Okay, so we already talked about the encryption. We can encrypt Zabbix front-end server and proxies when they're connecting to Postgres, no problem, as Alexander's just covered. Not the simplest task, but with these slides on your hands, you can just simply follow them. Should be easy, and the slides will be available to answer your questions, guys. I've seen you asking them on our events page, and also the video recordings will be available, so you can follow all of this step by step. And yeah, for Postgres, the TLS encryption checkbox will be disabled if we use socket connections. So that's also something that Alexander's mentioned. Next up, compression. So if we have deployed Postgres with timescale, and we have deployed the versions that support compression, we should see this here enable compression checkbox in administration housekeeping. And this means that compression is enabled if we're seeing these. This parameter cannot be less than 7 days. Right? So 7 days is the minimum. Compress records older than 7 days. We can only define a higher value for this. All late data, for example, data delayed by proxies or data sent with all timestamps by Zabbix sender that is older than these 7 days will be discarded. Right? It will not be written to the database. It will be discarded before it hits the database. And I will tell you, give you an example of why that is in a moment. But maybe if you wish to kind of maybe just jog your mind a little bit, try and figure out why that is on your own. It's a fun little exercise. So what would happen if we were to store older data, older than 7 days, that should be compressed already, how we would store it and what issues arise? So try and figure that out. And unfortunately, manual history cleanup is also not supported if compression is enabled. So you cannot just kind of select a couple of items and clear them out. So partitioning, next up, let's move from compression to partitioning. Partitioning for Postgres and timescale is enabled only if you select override item history or trend storage periods over here. So this here checkbox, right, needs to be checked in if we wish to use native partitioning. The TimescaleDB SQL script that we deployed a couple of slides ago over here, it enables these override checkboxes automatically. So if you're executing the script, you shouldn't worry about them. But this way, by removing these checkboxes, you can configure partitioning only for history and only for trends. Remove the checkbox from whichever isn't necessary. All right, so chunks, the kind of magic word, think of them as partitions. History and trend data gets automatically stored into these time-based chunks, so they have time ranges for them, similar to how partitions can be created, maybe to those coming from the world of MySQL or those who used partitioning on Postgres before timescale via scripts maybe. So TimescaleDB creates a new chunk with the corresponding time period, depending on the data that we receive as a part of the insert process. So if we're talking daily chunks and I have received data for today, then chunk for today will be created containing today's data. And this is per history table and per trend table. Chunks use different start end ranges depending on the type of hypertable, history or trend. So historic data is stored for 1 day, and trends are stored in chunks of 1 month, and history is stored in chunks of 1 day, not stored for 1 day, but these chunks are daily or monthly. So that's how you'll see them, and we'll look at them in a moment. So daily chunks for history, monthly chunks for trends. The chunk ranges, something to those of you who have maybe upgraded from an older version, from 4.4, for example, or older. They have changed over time. So in older minor versions, I think of 4.4, the trend chunk still was daily. It used the daily logic. And this caused issues. This caused, I think, some overuse of Postgres memory, because if Postgres has too many daily chunks or too many inserts into those chunks, something like that, it essentially bugged it out a little bit, and we saw Postgres running out of memory or overusing memory. So over time, we changed these trend chunks to be monthly chunks. And if you have upgraded maybe from 4.4 manually to 5.0 or a newer version, take a look at your trend chunks. Maybe you're still using daily chunks. This can be remediated. I have attached the ZBX, the bug report number for this. And you can find the full migration guide for it. In short, what you would have to do if you encounter a situation like this is rename trends to trends old, create a new empty trends table, and convert it to a hypertable with 1 month chunk interval with monthly chunks, and then migrate the data from 10 trends old to trends. With the migration guide in this here ZBX, it's relatively simple, right? The ZBX at the bottom, you can just follow those steps. If you have deployed Zabbix from 5.0 or newer, then you don't have to worry about it. You already have monthly trend chunks, so you're good to go. But if you were using 4.4 at some point, then or an older version, then be careful and double check. And we will look at this in a moment, how we can check this. So we can find existing chunks from the Postgres command line interface. Over here, select from TimescaleDB information.chunks. And here we can see our chunks. This is a history, trends in the middle. I can see the chunk range start and chunk range end in Unix time. If you aren't sure about your trend chunks, just plug this into a Unix time converter. See the start of the chunk, for example, today is December the 9th. And for example, if it's daily, you'll see that the start is December the 9th and the end is December 10th, right? So that means you have daily trend chunks, for example, and you will need to implement that fix. Once again, implement it in a test lab first, of course. If you're seeing your trend chunks last for a month, the start range is, say, start of a month, end range is end of a month, then you're good to go. We can also take a look at the chunks for a specific hypertable, of course. We simply add the where clause, where hypertable name is, for example, history or trends, if you wish to do that trends troubleshooting. These here queries, they depend on the TimescaleDB API version. They have changed over time. I actually got confused a bit. I was looking for older queries for older TimescaleDB versions, and those queries didn't work. So I had to look up queries for newer versions. So adjust accordingly. Just do some Googling. If these queries don't work, maybe you have an older version of Timescale. Google around, and you should be good to go. We can also take a look at the chunk sizes. If for some reason you have suspicion that some chunk for some reason is extremely heavy, we can take a look at that, select from chunks, and then we can take a look at chunks detailed size for a specific hypertable. And here I can see total size in bytes. Right, so that's useful if I maybe wish to manually delete some older chunk or something like that. And here we can take a look with this here example query. We can take a look at which chunks are compressed and kind of take a peek under the hood for our compression. So here I can see I have these here chunks over here for whichever table looks like it's for history. And I can see that one chunk over here, 114, is compressed. The rest are not compressed. Yeah, false. So when will your chunks get compressed? Let's talk about compression. Let's return to my question that I asked you earlier, the little exercise, right? Why can't we store older data than the compression sort of interval? So for example, if I have configured compress records older than 7 days, then on day 8, we will compress these chunks. Why we don't accept values older than 7 days in this example? Even if I don't have any chunks older than 7 days, why can't I just insert data and then compress it, right? What obstacle forbids me to do so? So this would cause some really weird behavior. So let's say I'm sending values, old values to Zabbix, right? Think of them as packets. I send a value number 1. I store it in a chunk that's older than 7 days. And that means that I instantly have to compress it because it's older than 7 days. And that means that the second value will be discarded, or any upcoming value will be discarded because the chunk already exists. And chunks are, when compressed chunks, once they are compressed, they are read-only. So that doesn't make sense. We would be storing only one value in our compressed chunks. That's why we discard everything older than the compression time window. Older than 7 days, we discard everything that's older than 7 days. So, and this is Zabbix that discards these values. They never hit the database. Older than 7 days, everything older than 7 days gets discarded by Zabbix. Never reaches the database. Another thing that I found extremely tricky, and those of you who want to do some calculations, you can figure this out on your own or try and figure this out. So what about these ranges? Start of the, for example, chunk range and end of the chunk range, and when will these chunks get compressed? So, for example, for trends, if the chunk size is 1 month for trends, of course, it will not get compressed every 7 days. Trends have monthly chunks. They will not get compressed every 7 days. Trends will get compressed after a month because we need to compress the whole chunk. We cannot compress a part of a chunk. And these chunks, so they're created with a range of 30 days. And you might assume that each of these trend chunks will begin at the first of every month. It's 30 days, right? Monthly chunks. The start range might be first of the month and the end range last day of the month, but this is not true. If you look at the, for example, if you scroll all the way back and if you look at the range starts and range ends for the trend chunks, you will find them to be a bit random. They are approximately beginning of the month, but they're not necessarily the first date because the chunk range gets calculated based on multiple factors when the start date the range start should be and the range end should be based on the time of the received value during which the chunk is created, and also depending on the chunk time interval. There are multiple factors, and actually I wasn't able to rig up like a definite formula to calculate the chunk start creation date. I did find some Stack Overflow post about it that had some formula for it, but once again, that's not really official. So I would have to dig in manually into the source code to figure it out. I haven't done so yet. You may want to do so. I don't think that it's very relevant. It will be approximately a month, and that's fine. And I don't really need to predict for which day the chunk range start is going to be. It's approximately a month, the range, and that's fine for me. So, and that's pretty much that. So we got some insight into requirements for deploying timescale, how compression works, how partitioning works, and we have some examples of commands that we can use when playing around with chunks, figuring out what chunks we have created, what are their start and end ranges, what is compressed, what isn't compressed, and so on. This can be extremely useful in troubleshooting. And now we have some time for questions. So let me stop sharing my screen here and let's see. I can already see a question in chat. What about performance and compression? So compression so far in our tests, we've seen large benefits for it. The compression rate is insane, and we've seen pretty much next to no performance impact. So right now, only positives, and the compression rate is something crazy, like 70-80% or something like that for those compressed older chunks. So it's really insane. Let's see what else. So migration from Postgres to Postgres with timescale with large history trends tables comes with a lot of downtime. Like I said, it's always very hard when someone asks me, is it going to be a long downtime? Is it going to be a short downtime? Depends on your IO, depends on your processing power, depends on how tuned your Postgres instance is, depends what you mean by large. Terabytes, gigabytes, hundreds of gigabytes, tens of terabytes, that varies. But yes, it might take some time during which your database performance will get affected. So yeah, do schedule a downtime period for it. Do you have an idea how to upgrade big 2 terabyte Postgres databases with TimescaleDB from version 12 to 10 to 12 or higher with minimal downtime? Haven't done so myself. I would probably simply deploy maybe a second. Well, it's a large instance, but to minimize the downtime, I would probably just deploy a second instance and then migrate all of the data there. Costly, yes, but it's safer and you won't have downtime on your primary instance while you're deploying Postgres 12, for example, and then you just have to migrate the data back to it, something like that. But I don't know by heart myself. Feel free to drop that question on our forums, subreddits. That's also very useful, or our IRC chats. Let's see what else. Is Postgres Pro Enterprise 11 certified? Does it support TimescaleDB Postgres 11? So Postgres 11 is quite old. I'm not sure myself because our latest versions don't really recommend using Postgres 12. Postgres was 11, right? 11 with timescale. Yeah, we don't support that. If you look at the requirements, it's Postgres 12 and Postgres 13. So I'm not really sure about 11. Okay, let's see what's next. Is it compulsory to use TimescaleDB? Can I use TimescaleDB with MySQL? So TimescaleDB is a plugin for Postgres. You can, of course, with Zabbix, you can simply use MySQL, right? MySQL, and then there are partitioning scripts available out there and partition your data that way. That's no problem. It's just that for today, we are focusing specifically on Postgres and timescale. But you can use MySQL, you can use Oracle, you can use MySQL forks with Zabbix. That's no problem at all. That works just fine. All right. And that is all, I think, so far. So yes, thank you everyone for attending. These here presentations will be available once again in our events page. Just navigate to zabbix.com, open up the events page, and in the next few days, possibly beginning of next week, we will have those slides there available for download, and also the presentation, the speeches will be uploaded to YouTube, and potentially we will also do a series of blog posts, just kind of summarizing everything that was discussed today. So thank you a lot, guys. It was a real pleasure. Thanks to my colleagues. Thanks to Alexandra from Postgres Pro. It was a real joy. And I hope we will have more of these and cover more different topics about Postgres, timescale, and other related features. Thank you, guys. Have a great day, and I'll see you next time.